So this video will be about coloration analysis. I'll talk about how to make a coloration analysis in the analysis matrix in the next video, but here I'll just talk about how to perform coloration analysis in SPSS. I'll also just talk about the basics of coloration analysis. Okay, so there are two main types of coloration analysis. There's Pearson coloration, then there's Spearman coloration. Pearson coloration is a parametric test for coloration, then Spearman is a non-parametric test. A parametric test of coloration, or any parametric test, that means you perform that test. That's if you've satisfied the prerequisite conditions of passing normality. So you have to pass normality tests. That means your ketosis and skewness has to be in plus or minus 2, within the range of plus or minus 2. Then you have to pass the Kolmogorov, Shminov, and the Shapiro-Wilk test. Now for Likert scale data, it fails the Kolmogorov, Shminov, and the Shapiro-Wilk test. So you can proceed if your ketosis and skewness are in the range of plus or minus 2. Now, what is coloration? Coloration is a measure of relationship between two variables. It measures the type of relationship between two or more variables. So the type of coloration I'll be talking about is the bivariate coloration, where we have two variables. Then there's multivariate coloration, like regression. Multiple regression analysis is a form of multivariate coloration. That means the principles that I'll talk about, they will also apply in regression analysis as well. Regression analysis or multiple regression analysis, or even hierarchical, there are many types. It's basically multivariate coloration. So according to Palant, coloration ranges between -1 and +1. This just shows you the direction or nature of the relationship. What do I mean by nature of relationship? Are the two things we are comparing in the case of bivariate, are they related to each other or not? So if they're related to each other, they will have a positive coloration. If they're not related to each other, they will have a negative coloration. So the negative coloration will approach 1, which is a perfect negative coloration. But in the real world, that's most likely impossible for it to reach a negative coloration, negative perfect coloration. Same thing with the positive coloration. In the real world, the chances of things having a positive, perfect positive, are very unlikely. So that's for according to Palant. According to Cohen 1988, Cohen talks about the sizes of the coloration. So now it's important to know the difference between the sizes and the nature of the coloration. The nature just deals with whether things are related to each other. Then the sizes talks about the magnitude, the strength of the coloration. So colorations between 0.1 to 0.29 are considered to be the small range or small effect size colorations. Colorations between 0.3 to 0.49 are considered to be the medium range colorations. Then colorations between 0.5 and 1 are considered to be the large range or large effect size colorations. Now these can be both negative, can be either negative or positive. So they can be either negative or positive. Then with the bivariate coloration matrix, it only shows statistical significance of 0.05 or 0.01. So basically 5% to 1%. So basically 2 asterisks, that's the highest it can go. 1 to 2 asterisks. So if you can see this diagram, this one has got 1 asterisk, then the other one has these, most of them have got 2. So they are called two-tailed coloration, two-tailed tests. So when interpreting coloration, I'll show this in SPSS. But when you're comparing colorations, or when you want to interpret this matrix table, you only you use the first column for interpretation. So you compare things against the y variable. So the first variable you put in SPSS is the y variable. So you compare everything against the y variable. If you've got the mediator, you put the mediator before the control variables. Now you have to have control variables in any research. Control variables are variables that we hold constant so that we can determine which x variables are spectators. What does that mean? So control variables prevent you from attributing explanatory power to x variables that don't add anything. So in this case, we want to know if these x variables do contribute anything. So we control for these other factors like age. How does age affect entrepreneurship? Like the younger you are, the more likely you're going to be open to risk taking. Then the older you are, the less averse you are to risk taking. Gender is also a factor. So some gender affects entrepreneurship intention, so we have to factor in that. So in this one, school type was just this research was done for university students, so I was comparing business students and non-business students. So we found that I was just factoring that as a factor because entrepreneurship is more of a business related thing. So if that's a factor, so I just had to control for that. Then entrepreneurial education as well is a factor, whether you are business or non-business. If you had some form of training, I just had to control for that. Yeah, so those are control variables, and they are unique to any different types of research, so they are not just fixed. But usually we control for age and gender most of the times. Age and gender is usually is always there most of the times. Yeah, so that's it for control variables. So if you had the mediator variable, you would place it here second to the y variable, then you put the control variables. Yeah, so let me just perform coloration analysis using the SPSS dataset. So you go to analyze, scale, analyze, colorate, bivariate. Let me reset. So in this dataset, we will assume that subjective norms are a mediator variable. So we click the y variable, entrepreneurship intention. Okay. Subjective norms, and we go to our covariates, so control variables, gender, age, school type, entrepreneurship education. We click there's Pearson and Spearman, so we click Pearson, Spearman. We make sure we are set at two-tailed test. Flag significant, this is usually on default. Then we go to options, means and standard deviations. Exclude cases, pairwise, not listwise. Cases pairwise allows you to factor in variables with some missing values, so it allows you for greater utilization of the sample. So in case there are some variables with missing values, listwise will exclude them from some certain tests. Otherwise, pairwise will include them, while listwise will automatically exclude them. So we can press OK. Then there's this is the non-parametric. Okay, I think I've made a mistake. I forgot to include the x variables. So analyze, correlate, bivariate. Yeah, I forgot to include the x variables. Now, when you first perform correlation analysis, you take note of the sizes of the correlation, so that you can arrange the variables from smallest to largest. So in this case, I know this one is small, the smallest. This one follows, that one follows, this one follows. These are in order of size. Okay, then we press OK now. Now this is perfect. So this is the largest, followed by that, followed by that. But you won't have this when you perform this for the first time, so you just have to take note. Then you can go to analyze, correlate, bivariate. So if this one was the largest, you can drag it down. But it wasn't, so we just leave it there. Okay, cancel. This is the non-parametric. So since we passed normality, we use the parametric version of, parametric test for correlation. So I'll be, in the other video, I'll be making a correlation matrix table. So what you do is you copy this, paste special text only. So I'll talk about making the correlation matrix table. Then I also talk about other details, like it would be better if I explain what multicollinearity is in Excel. I'll highlight the parts, but I can just explain what it is right now. Now, multicollinearity is a special case where where two or more variables are so related to each other such that the correlations, the multicollinearity usually starts at 0.8, but at 9 then we have multicollinearity there. So 9 approaching 1, we have severe multicollinearity. 8, that means there might be some moderate multicollinearity. Yeah, so this first column we use for interpretation. Then these are the at the diagonals here, that's where we check for multicollinearity here. So these are the x variables, so we check what is the highest correlation we can see here. So far it's 0.697. So this shows the correlation amongst x variables, the relationship between them. So none of them have correlations of 0.8, or most severely 0.9. Yeah, so if we have got the 0.9, that means there's multicollinearity. Then to confirm multicollinearity, we look at the variance inflation factor in regression analysis. Yeah, so if the variance inflation factor exceeds 10, that means there's severe multicollinearity. If it's close to 10 but below 10, that means there's moderate multicollinearity. So it will be better, once I make the Excel diagram, I'll highlight which areas where you have to look at. Then you'll be able to tell that, okay, there is multicollinearity, there's no multicollinearity. and just the how to explain the interpretation again. I also highlight which areas, and I'll talk about how to explain the interpretation in a more time efficient way. Yeah, so that's it for this video.